Hey folks, I'm Mr. Hartzler and I want to talk to you about dividing polynomials. These can be a little bit tricky, so we'll just go slow and take our time here. Dividing polynomials by monomials. So that's poly or many nomials or many terms by mono or one monomial. You know what I mean. One term or many by many terms. Okay. Find the quotient of this chunk and this chunk. That really just means have this first thing on top and that second thing on bottom, like I have for you here. One of them is the factoring method. So this one here, we're going to leave all of that top over this one thing on bottom, but we're going to factor that out of every single one of these terms. So I need to pull 7xy squared out of the whole rest of that top, or at least as much of it as I can. But in this case, it will actually be all of them. So 21 divided by, or factoring out this 7, which means I'm dividing by it. What's 21 divided by 7? I'm left with 3. I have x cubed, and I'm dividing it by x, because I'm factoring out an x. I'm left with x squared. And then y squared divided by y squared. No more y's. Now I have a 7 x squared y cubed. Dividing out this 7, I'm left with just a 1, which I don't have to write. X squared, I'm dividing out an x, so I'm still left with an x. Y cubed, factoring out y squared, so there's just a y left. And then minus, because there is that minus there. 14, factoring out a 7, so I'm left with 2, right? Because 14 divided by 7 gets me that 2. And then I have x dividing out an x, so there's no x's. Y to the 4th, divided by y squared, left with y squared. So again, I factored out as much as I could of whatever that denominator was. And in this case, it actually is all of these things. It sometimes isn't, but a lot of the times, at least for us for this section, it is going to be. And now, because it's all factored out, I can cancel it. And then my answer just is that chunk in parentheses, the 3x squared plus xy minus 2y squared. That just is my answer now. There's another method to this, though, and it's this distributive division, which means I'm taking each of the top terms and I'm dividing it by that same denominator. So this is the exact same problem, just a different strategy. So now this, I think this can sometimes be easier, especially early on when you're still learning this. So now I have a 21 over 7. That gets me 3. X cubed divided by x. So that's like a 3 on top, right? And 1 on bottom. So one of those are going to cancel. And I'm now left with an x squared. And then I have y squared over y squared, so they cancel out entirely. Now I have a 7 over 7, and they cancel. X squared over x, so there's 1 left on top, right? Because if I had x squared over x, right, that's the same as x squared, just 2 x's next to each other. And one of those, like let's say that one, cancels with that one on the bottom, and I'm just left with 1 on top. Ooh, don't want to go forward yet. Yeah, it's a word problem though. It'll be okay. All right, so there's 1 left on top. Y cubed over y squared, left with a y. And then my next one, I have a negative out in front. 14 divided by 7 is 2. X over x, they cancel. Y fourth over y squared, I'm left with y squared. Same answer, because again, this was the same problem, but these are two different strategies. If you're not really strong with factoring, try this one where you're literally just dividing each piece at a time. All right, next one. The area of a rectangle is this thing, square units. Don't worry about that part. It just means like inches cubed or miles cubed or whatever. If the length of the rectangle is 5xy, what is the width of the rectangle? Okay, so let's think about rectangles. The area is width times length. So I know that 30x cubed plus 55xy squared equals my area. And they told me length is 5xy, so I know L equals 5xy. Let's plug that into my formula for area and see what we get. So I know my area is this. And that equals width times my length, which I know is 5xy. And they're asking what's the width? Well, I need to find w, so I'm going to divide by 5xy. Divide by 5xy. All right, and I'm going to kind of do a combination here. I'm going to divide each of my numerators by my denominator. So I'm going to do the distributive property, or the distributive division, but I'm not going to actually write it out, okay? So I'm just going to do it right here. 30, let me do this in a separate color here. 30 over 5xy. 30 over 5 divides, gets me 6. X cubed divided by x is going to get me x squared. Now I don't have any y's on top, and I'm dividing by a y. That means I have to leave a y on the bottom. All right, now I'm going to do my other one, and let's do it in blue. Hopefully people aren't blue-green colorblind. All right, so now I'm going to divide these two things, right? Because they're both over that 5x. Everything on the top gets divided by that 5x. So 55 divided by 5 is going to get me 11. X over x, they're going to cancel. X or y squared over y, I'm left with 1y on top. And that is my answer. That's what w equals. And that's what they were asking for, is my width. Awesome. Done. Next one. Find the quotient. Well, quotient is dividing, right? So divide this and this. Okay, so that's like a squared minus 9 over a plus 3. And they wrote it in parentheses, which seems significant. I'm not going to write them for a second. And we'll just see what happens. Oop. There we go. Skipped ahead. You'll notice here, this is now two terms. This are not monomials I'm dividing by. And when they're not monomials, I actually have to do a little bit more work. I need to first see if this will even factor. That's always going to be the easiest path for me. Since there's two terms separated by subtraction, I know it has to be either the difference of squares or the difference of cubes. And since a is being squared, I'm guessing it's difference of squares. And you can look at previous videos, but I know that factors like this. A minus 3, a plus 3. I could also do that by what multiplies to get me a negative 9, but will add up to get me 0 middle terms. And then this is still all divided by a plus 3. Now, I'm going to throw these parentheses in. You can take them or leave them like that, right? Now maybe you'll notice that we have an a plus 3 on top and an a plus 3 on bottom. They can cancel. And if they cancel like that, and I only do that because everything in the top is being multiplied together, and there's nothing else in the bottom, so I'm left with that a minus 3. Awesome. Another way of thinking about this is we could factor out a plus 3 in the top, right? It's kind of over there already, and I'm dividing by a plus 3, and that is the factoring method like we talked about earlier on. Alrighty, next one. Find the quotient of that. Wow, there's 4 terms there, and then this is 2 terms. So we call that still a binomial, bi meaning 2. All right, I'm going to write this one up differently because we're actually going to do this the long division way. When there's that many terms, we're going to do long division. And when we're dividing by a binomial. So I'm going to write out that thing up top. 2x cubed plus 3x squared minus 17x plus 12. And I'm dividing all of that by 2x minus 3. Now, I ignore the 3 for the first part of all of these little sequences. So 2x cubed, divide it by 2x. 2's cancel. X cubed divided by x, and I end up with just an x squared. Now I take that x squared and I distribute it to both of these terms. So I get 2x cubed minus 3x squared. I wrap it up in parentheses and I subtract it away. This is exactly the same as if I were doing long division with anything else. So if I'm dividing these by, let's say, 3. No, let's change that to a 4. Okay. So, no, not a 4. Yeah, 4. We'll do a 4. It's fine. Okay. I take that 4 and I divide it by 3, and I get 1 evenly. So 1 times 3 is going to get me 3. Then I wrap it up and I subtract it away. And now I get 1, and I'm just bringing the other stuff down. 3, 4. Okay, now how many times does 1 go into that front stuff? 13. That's going to be 4. And I distribute that 4. Gets me 12. I subtract it. I get 1, and then I bring down my 4. And then that's going to be 4. And I distribute it in, and I get 12. And I subtract them. I'm left with 2, and that's my remainder of 2, or I could also write that that's 2 over 3, because I still haven't divided that 2 by that 3. Okay, now I'm going to erase all of that, and we're going to keep going. But it's that same principle as if you're doing long division. So if you're bad with long division and with numbers, you might want to revamp that a little bit and check it out. All right, so now I've wrapped them up, and I'm subtracting them. This first term, all of this, should cancel. I didn't in the last one with just the numbers, but for us here, it should always cancel. So now I have 3x squared minus a negative 3x squared. Double negatives get me positive 6x squared, and it is just x squared, so I'm not adding up those exponents, okay? I would only do that if I were multiplying x squared and x squared, and I'm just adding terms with x squareds, right? Okay, now 6x squared, my new thing in front. I'll bring all these things down. My new thing in front, divide it by the thing out here. And what is 6x squared divided by 2x? Well, that's going to be 3x's. Take that 3x and distribute it in. Let me change my color up. I'll do white here. 3x times 2x gets me 6x squared. 3x times a negative 3 gets me negative 9x. Wrap it in parentheses, subtract it away. My front terms should cancel. Good. If they don't, something is wrong. Negative 17x minus a negative 9x. That means there's double negatives there. What's negative 17 plus 9? That's going to be a negative 8x. And then that 12 is going to come on down. Negative 8x, it's my thing in front now. Divide it by 2x, and I get a negative 4x. Oh, no, sorry. No x's, just negative 4. Then I distribute that negative 4 to both of those things out front, and I get a negative 8x. Negative 4 times negative 3 gets me a positive 12. Wrap it up in parentheses, subtract it away. 8x cancels because you don't remember double negatives, so I'm not adding that. 12 minus 12 gets me 0. Nice. So this is x squared plus 3x minus 4. I don't have to write anything else because there is no remainder. Another way of writing this, let's say if I did have a remainder, right? If we were just pretending for a second and we got like a 3 down there, I would write x squared plus 3x minus 4 are 3. Or, if I didn't want to write a remainder like that, I could write plus 3 over 2x minus 3. Either one of those are usually viable options. This one is the slightly fancier option. And again, that's only for pretending we had a remainder of 3. Okay, we didn't actually, and that's why this is our final answer up here. Alrighty, thanks for watching, folks. Sorry for such a long video, but it's a lot of material. Have a great day, everybody.